Today, we are going to pull back the curtain on probably the single most important idea in modern AI, supervised learning. It is the secret sauce, the quiet engine behind some of the most amazing and, some of the most ordinary tech you use every single day. I mean, have you ever really stopped to think about it? How does your email inbox just know what's junk and what's important? Or how does your phone unlock just by glancing at your face? Come on, that's wild. Well, these aren't just clever programming tricks. They're the result of a very specific and very cool learning process. And believe it or not, the answer to both of those questions is exactly the same thing: supervised learning. It's a fundamental concept that has been a total game changer for AI, and today we're going to break down exactly how it all works piece by piece. So how on earth do you get a machine to actually learn something? Well, it turns out the most straightforward way is to do what we do with people. You just teach it by showing it a ton, and I mean a ton of examples. Okay, so here's the core idea. We give the machine a massive data set, but the absolute key here is that this data is labeled. Now, what that means is that every single piece of data already has the correct answer attached to it. It's kind of like giving the machine a giant stack of flashcards with the answers already written on the back for it to study from. At its heart, the process is pretty simple. You feed the machine an input, say a picture of a cat, and you also provide the correct label, cat. Or you give it the text from an email, and you tell it, yep, this one's spam. You do this thousands or even millions of times, and eventually, it starts to see the patterns all on its own. And that really gets to the whole point, right? The goal isn't just for the machine to memorize the old examples. No. The goal is for it to learn the underlying rules so well that it can make accurate predictions about brand new stuff it has never, ever seen before. So we get what it is, but how does this learning actually happen? Let's peel back the next layer and break down the process, step by step. It's a pretty logical four-step dance. First up, you need the data, and not just a little bit, you need a huge amount of good labeled data. Then, and this part is crucial, you split that data into two piles, one for studying and one for the final exam. During the training phase, the algorithm just churns through that study data, looking for patterns and tweaking itself over and over. And finally, you evaluate it. You hit it with that exam data it's never seen before to find out how well it really learned the material. Okay, two quick bits of jargon you're going to hear a lot. First, features. These are just the input variables. So if we're trying to predict a house price, the features would be things like the square footage, its location, the number of bedrooms. And then there's the label. That's simply the correct answer we're trying to predict. In this case, the actual selling price of the house. See? Features are the clues. The label is the answer. And I love this analogy because it just makes perfect sense. The training data is the textbook. It's everything the model gets to study from, complete with all the answers in the back. But the testing data? That's the final exam. It's full of questions the model has never seen, and this is how we find out if it actually learned the concepts or just memorized the book. All right, now this is where it gets really interesting. Supervised learning isn't just one size fits all. It has two main superpowers, or two major types of problems it's just incredibly good at solving. The two powers are called regression and classification. And here's the absolute key difference. If you're trying to predict a specific number, like the price of a stock, or the temperature tomorrow, or the cost of a house, that is a regression problem. But if you're trying to predict which category something falls into, like spam or not spam, cat or dog, that's a classification problem. So it all boils down to, is the answer a number or is it a label? Okay, let's bring all this theory back down to earth. Let's look at how these superpowers are quietly working behind the scenes in the technology we use every single day. Take a look. That spam filter we keep talking about? That's a classic classification task. A real estate app that estimates house prices, that's regression, trying to land on a specific number. Medical systems that help doctors diagnose diseases, they're classifying symptoms. And businesses forecasting next quarter sales, that's a regression problem. Once you know what to look for, you start seeing it everywhere. So why is this one idea so incredibly important? Well, because it just works. It's extremely accurate for a huge range of real-world problems. But here's the catch. Its greatest strength is also its biggest weakness. It is completely 100% dependent on humans to give it massive amounts of perfectly labeled data. Without that supervision, it can't learn a thing. Still, because it's so powerful and reliable, it remains the absolute backbone of practical AI today. And that brings us to a final, pretty deep thought. The power of supervised learning comes from the labeled data we give it. It learns from our examples. So the crucial question we're left with is this. If an AI always needs a human supervisor to provide all the answers, how can it ever discover something new or learn about things that we ourselves don't yet understand? It's definitely something to think about. Thanks for joining me.